In this video, we're going to take a look at chemical equations, what they're made up of, and the different parts. Here we have an example of a chemical equation. First, we can see that we have the chemical formulas for different compounds. Starting from the left, we have calcium carbonate, we have hydrogen chloride, we have carbon dioxide, we have water, and we have calcium chloride. Note that all of our compounds are separated either by arrows or by plus signs. The first part of our equation is what we would call our reactants, and the reactants are what we start with. We read our chemical equations from left to right, so we're starting with our calcium carbonate and our hydrogen chloride. The separation between reactants and products is our arrow. The arrow generally means that we are going to yield or we're going to produce our products, which are on the right-hand side of the equation. Our carbon dioxide, our water, and calcium chloride are our products. The next set of symbols that we want to focus on are state symbols. In a chemical equation, many times it's good to know what the states are for the compounds, so we have an idea of what it would look like if we were actually to carry out the reaction. In this case, we have solid calcium carbonate, represented by the S. We have aqueous hydrogen chloride, and technically we would call it hydrochloric acid. The aqueous means that the HCl, the hydrogen chloride, has been dissolved in water. On the product side, we have gaseous carbon dioxide, we have liquid water, and we have another aqueous compound. Since the reaction has an aqueous solution beginning of the reaction, the hydrochloric acid, our calcium chloride is going to be dissolved in that same liquid. We also have the presence of water, which means it can be dissolved in that water. The last symbol that we have is actually one that's shown and several that are hidden. Our coefficients represent how many of each molecule or how many of each compound is going to be required for the reaction to take place. In this case, we need to have 2 hydrochloric acids or hydrogen chlorides for the reaction to take place. All the other compounds only require 1 molecule of each compound, so we represent those with 1, but that's understood, so we just drop those and don't write them. The reason why we need to have the coefficients is so that we can have what we call a balanced chemical equation. And a balanced chemical equation is going to be an equation that represents having equal numbers of each atom on both sides of the equation. In this case, if we start off with 2 hydrogens, because we have 2 hydrogen chlorides, we're going to end with 2 hydrogens. In this case, the 2 hydrogens in our water. We also need to have the 2 chlorines on the reactant side to balance out with the 2 chlorine atoms on the product side. This is basically our structure and setup for a chemical equation. We have the reactants on the left, products on the right, state symbols telling us what state we're going to find these compounds or elements in, and the coefficients telling us how much of each one.